Assalamualaikum warahmatullahi wabarakatuh. Today I would like to talk about the color of star. What is a star and what kind of star colors? When you look up into the sky, you will see the star twinkling in different colors. Some are dull and red, while others are white and others look bright blue. So, how do you get so many different star colors? But first, do you know what is a star? Star is a luminous ball of gas, mostly hydrogen and helium, held together by its own gravity. Nuclear fusion reaction in its core support the star against gravity and produce photons and heats, as well as small amounts of heavier elements. Next, we will find out why star has many colors. Star has color for two reasons. First, because of their temperature. The color of a star depends on its surface temperature. For example, our sun. Our sun's surface temperature is about 6,000 Kelvin. Although it looks yellow from here on Earth, the light of the sun will actually look very white from space. This white light coming off of the sun is because its temperature is 6,000 Kelvin. If the sun were cooler, it will give off the light more on the red end of the spectrum. And if the sun were hotter, it will look more blue. And so is the star. The coldest will be red and the hottest will be blue. Astronomers have long used stars' temperature to identify their color, and they create a classification system called spectral classes to do so, which places stars into a category based on their temperature. Class O star, which are blue in color, are the hottest, and Class M star, which are red in color, are the coldest. This can be tricky to remember, as we typically think of blue as a cool color and red as a hot one. Thus, it's helpful to understand the reason blue stars are hot and red ones are cool. Remember that the temperature of an object is a direct measure of the amount of motion within it. The hotter star, the faster its particles move and the more energy they radiate. Cool stars radiate most of their energy in the red and infrared region of the electromagnetic spectrum, which means shorter wavelength and less energy. And the second, because of the age. Throughout most of a star's life, it is burning hydrogen at its core, which creates a lot of energy and thus makes it appear blue. As stars age, they run out of hydrogen to burn, decreasing the amount of energy they emit. Thus, younger stars can appear blue, while older ones can appear more red. And in this way, a star's age can tell us something about that star's color. Now, we will discuss the kind of color in star and example of the star. The first is red giant star. Red giants are supergiant stars of spectral type K and M, and a luminosity class of 1. They are the largest star in the universe in terms of physical size, although they are not the most massive. Stars with more than about 10 solar masses after burning their hydrogen become red supergiant during their helium burning phase. These stars have very close surface temperature. It's about 3,500 to 4,500 Kelvin and enormous radii. The four largest known red supergiants in the galaxy are Mu Cepae, KW Sagittarius, V354 Cepae, and KY Cygni, which all have radii about 1,500 times that of the Sun. The second is white dwarf star. When they reach the end of their long evolutions, smaller stars, thus up to 8 times as massive as our own Sun, typically become white dwarfs. White dwarf stars are supergiant stars of spectral type A and F. The stars have surface temperature 180,000 degrees Fahrenheit. These ancient stars are incredibly dense. A teaspoonful of their matter would weigh as much on Earth as an elephant, 5.5 tons. White dwarfs typically have a radius just 0.1 times that of our own Sun, but their mass is about the same. Stars like our Sun's fuse hydrogen in their cores into helium. White dwarfs are stars that have burned up all of the hydrogen they once used as nuclear fuel. Fusion in a star's core produces heat and outward pressure, but this pressure is kept in balance by the inward push of gravity generated by a star's mass. When the hydrogen used as fuel vanishes and fusion slows, gravity causes the star to collapse in on itself. And the last is blue giant star. Blue giants blaze with a surface temperature of 20,000 Kelvin or more and are extremely luminous. Just for comparison, a star like our sun only has a surface temperature of about 6,000 Kelvin. A blue giant star can put out 10,000 times as much energy as the sun. Astronomers categorize blue giants as type O or B stars, belonging to the luminosity class 3. They can reach an absolute magnitude of -5 or -6. The true monster of the universe are blue supergiant stars like Rigel. This can be a blue star with surface temperature of 20,000 up to 50,000 Kelvin and can be 25 times larger than the sun. Because they're so large and burn so hot, they use up their fuel very quickly. A middle-sized star like our sun might last for 12 billion years, where a blue giant will detonate with a few hundred million years. The smaller star will leave neutron stars or black holes behind, while the largest will just vaporize themselves completely. I think that's all I can say about the color of star. I hope it's useful for you all. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.